Alright, we changed this problem a little bit, and the problem is we're going to be finding norms. So, which of the two vectors are closest to each other in distance? So we're going to find the distance between two vectors. We take the norm of the two vectors, okay? So there are three different kinds of norms they're asking us for. The Euclidean norm, which is the traditional one, where you do the sum of the squares. Okay, so x squared plus y squared. You add them up, take the square root. That's related to the Pythagorean theorem. That is also called the L2 norm. Next we have the infinity norm. I think of it as the maximum norm. It's basically the L1 norm, but you just take the maximum value. And finally we have the L1 norm. So, to figure out the Euclidean norm distance, we have to do three different things. Because, let's just imagine the vectors. We have u, just shooting out there. Then we have v. And then we have w. How do we figure out which two vectors are closest to each other? What do we have to measure? Well, we have to measure the distance between w and v. We have to measure the distance between v and u. But we also have to measure the distance between u and w. So we have to measure the distance between three different norms. So essentially we have to find the norm, the L2 norm of u minus v. And this, the order doesn't matter. You could do v minus u and you're still going to get the same thing because you're taking the absolute value or square root. Because distance is absolute. It's not relative to each of the two things. Okay, it's relative to each of the two things. It's not relative in general. Okay, so I'm talking about the distance between here and the store. It's the same distance from here to the store as it is from the store to here. So that's why distance doesn't matter like that. Mathematically, there's probably a better way of proving it. That's just how I intuitively understand. Okay, now my camera's focused. I had to move. Next, let's do the L2. Do the L2 norm of v minus w. Then we have to do the L2 norm of u minus w. Alright, so let's first figure out what each of these subtracted by each other are. So u minus v is equal to u, which is 1, 2, 3, minus v, which is 2, 5, 2. That equals 1 minus 2 is negative 1. 2 minus 5 is negative 3. 3 minus 2 is 1. So this is u minus v. To find the norm, what we do, take the square root, negative 1 squared, plus negative, well, what are you doing? Yeah, plus negative 3 squared, plus 1 squared. So this equals, so 9, 1, 1, 9, 10, 11, square root of 11. Alright, let's do the next one. The next one, we'll give it a little more space. V minus w equals vector v 2, 5, 2. I mean, if you can do this all in your head, more power to you. I'm going to make a mistake either way. So, negative 1, 0, 0. So 2 minus 1 is just 2 plus 1, so 3. 5 minus 0 is 5. 2 minus 0 is 2. So that's what that is. Now, let's do the square root of 3. 3 squared is 9, plus 25, plus 4 equals square root of 25, 29, 38. Alright. Our final norm, u minus w, equals, for u we have 1, 2, 3. For w we have negative 1, 0, 0. That equals 1 minus negative 1 is 2. 2 minus 0 is 2. 3 minus 0 is 3. So we're going to have the square root of 2 squared, 4, plus 2 squared, 4, plus 3 squared, 9. That equals the square root of 4 plus 4 is 8 plus 9, 17. So those are those three. So which two are closest? U and V are closest. Okay. Let's do the next one. I'm just going to copy our vectors up here so I can see them. Drag this baby down here. We're going to do part B now. The infinity norm. Okay. So, infinity norm is pretty similar. I think you'll kind of understand it as we go through. But again, we have to find the distance between all three. So we have u minus v, normage to infinity. Then we have v, well, we have u minus w. Let's do that. That is to infinity. Then finally we have, we write the v a little different so we can see it more clearly. V, people do that. I swear people do that, I swear. Okay, and then V minus W. I'm glad I can make myself laugh because no one else will. No, I mean, no one else will laugh at me. That's what I mean. Alright. So, we actually already found these vectors up here. So we can just bring them down here. Select, copy, paste, drag, put it here, and then we'll do u minus v. Shouldn't have switched the order, shouldn't have messed with how things were going. Okay, u minus v. So the infinity norm is we take the absolute value of each of these. So I do the absolute value of -1, absolute value of -3, and the absolute value of 1. We find the max, which equals 3. Okay. Now, we switch these around. So we're going to have the absolute value of 3, 5, and 2, but since they're already all positive, equals 5. And then we're going to have, oh, that's actually the next one. See, I switched them. I knew it was going to cause me problems. Why did I do it? Why did I agree? Why did I do this to myself? Okay. Now we're going to do this one here. So absolute value of 2, 2, and 3. Max equals 3. Okay. Huh, this is suspicious. Okay, so it looks like the distance between U and V equals the distance between U and W. U is equidistant. I didn't spell that right. I'm like confident. That's what you do, is if you can't spell something, just scribble at the end. The mistake is already obvious. There's something going on. Equidistant. Maybe it is right. I don't know. U is equidistant from V and W. Yeah, U's right in the middle. Alright, C, the L1 norm. Now the L1 norm is really similar to the infinite norm. Just pulling it up. Yeah, the L1 norm, you just take the sum of the absolute value. So it's kind of like the max norm, where you take the absolute value, but this time you just take the sum. So let's do that. U minus V. We'll do it the right order this time. V minus W. And U minus 3. Alright. We'll copy these guys again. Drag them down here. Alright. Absolute value of -1 plus the absolute value of -3 plus the absolute value of 1 equals 3 for 5, 5. So then equals 3, 5, 2. Since these are all already positive, 5, 6, 7, 8, 9, 10. 10. And we'll just do these. 2 plus 2. 3, 4, 5, 6, 7. 7. U and V are closest. In L1. Alright, let's just underline our answers. And I think we are good. Thanks for joining us.